Okay, let's do problem number 20. Okay, so basically here we have a p-value of 0.035. Here's my p-value. If alpha is greater, we're going to reject it. If alpha is less than, we're going to fail to reject. Okay, so if alpha is 0.05, that means alpha is greater than, and we will reject. So the answer is not A. At alpha 0.04, okay, which would be less than, so the answer is B. Okay, a tire company guarantees that a particular brand of tire has a useful lifetime of 42,000. A contestant agency, which of the following would be used to test the manufacturer's claim? The mean lifetime was to observe. Remember, we want to verify the claim. To observe 10 tires on a set. Okay, so this is a means, okay? And so, brand I use time, just verify, observe 10 tires. Together, test it. Want the data, which of the following be used to test the manufacturer's claim? Okay, whenever we want to test a claim, we're doing intervals, okay? So this would be a one prop interval, so the answer is A. Okay, so number 22 here, they're talking about buying copiers, and they want to do a type 1 error. So this is when HO is true, but we go with HA. So what we do is that we decide to purchase a new copiers and find them not to be more reliable because HO is true. So the answer is B. Okay, survey of 24 women, glycerin. What is the number of degrees of freedom here? Now remember, 25 is just their age, but how many females did we get here? Oh, we have 10 females, so 10 minus 1 is 9. See, that was tricky, wasn't it? Okay, so here we're at a pit stop, and we're saying that we can change all 4 tires in 15 seconds. So do you agree with me that all our HOs are always equal to? So these two are out. Now, think about this. If they're trying to get the tires on, is it better to have them less than 15 seconds or more than 50 seconds? It's less than 50 seconds, so the answer is D. Okay, so let's go do number 25. And so remember, a confidence interval for a one mean is going to be this mean plus the critical value of the degrees of freedom times the standard deviation divided by the square root of n. Well, my mean is 3.1, and do you see here that everybody has 3.1? So that is fine. So is what is to the right of here. So let's go find my t star. So if I have a 99 confidence interval, so that means that my critical value, I'm going to go to inverse t, and I'm going to put in 0.005, because that's half of 0.01 with the degrees of freedom of 49. And, it's gone, it's gone. And I get 2.68. Okay, so I'm going to do in 2.68. My standard deviation is 0.3, and my n is divided by the square root of 50. Okay, so I'm going to take what I got, and I'm going to multiply it by 0.3, and then I'm going to divide it by the square root of 50, and I get 0.11. So the answer is B. Okay, let's do number 26, and here they want us to solve for n. So do you see that I have set it up? We know that margin of error is equal to t star times my standard deviation divided by the square root of n. Now this is a catch-22. Remember, we can't use z star because z star relies on degrees of freedom, and degrees of freedom relies on n. So we have to use Z star. So Z star for 90% is 1.64. So here is my formula. So the first thing I'm going to do is I'm going to take 10 and I'm going to divide it by 1.64. And I get 6.09. So I'm going to get 6.09 is equal to 100 divided by the square root of m. So these two do the do-si-do, so I get the square root of n is equal to 100 divided by 6.09. So I'm going to keep that number in my calculator. I'm going to do 100 divided by my answer was at 6.09, and I get 16.4. So I get the square root of n. The square root of n is equal to 16.04. And so I'm going to square that number because I want n, and I get 268. So the number closest to 268 is C. Okay, by now you should know that I really like those questions. Okay, let's do number 27. The least square regression line for a scatter plot is y hat is equal to 0.56 plus 0.61x. What is the residual for the 0.31? So we know that y is equal to 1. You see that? We know what y is equal to. So y is equal to 1. So I'm going to plug 3 into this equation. So 0.56 plus 0.61 times 3. 0.61 times 3 plus 0.56. And I get 2.39. And so the residual is equal to y minus y hat. So it's going to be 1 minus 2.39, and I get negative 1.39, so the answer is B. Okay, let's go to number 28. Which of the following can reduce the size of the confidence interval? Well, you know, we have our Z star, right? And so really that has a lot to do with it, okay? That's part of the margin of error. And that relies on the level of confidence. So to reduce it, if I go from a 95 to a 90, it becomes tighter. So the answer is C. Reduce the level of the confidence interval. Okay, let's see if I can do these type 1, type 2 errors here. A piece of medical equipment is not functioning properly, but however, in the running operation, a lab technician does not find evidence of the malfunction. The lab condition. Okay, so let me think about this. Okay, so typically when we have something, we believe that there is no malfunction. So that would be my AJ, and the fact that there is a malfunction, that would be my AJ. Excuse me, no malfunction, everything is fine, would be an HO. The fact that there is a malfunction would be an AJ. Now the AJ is true, but we decided to go with HO. Then when we do that, we committed a type 2 error. You need to know that. Okay, so basically what we want to do is degrees of freedom here. Remember that's row minus 1 times column minus 1. So my rows are 3 minus 1, which is 2. Column minus 1, which is 2 minus 1, which is 1. So my answer is 2. Sorry, that's sloppy handwriting. Let's go here to number 3. Excuse me, number 31. Do you see that these are just hours of the length of time that brand A worked and then the brand B? And so remember, if I was to take this guy here and put it right here and I moved all of these over, I wouldn't change anything. So because of that, this is a 2-sample t-test. This is not a paired. All right, now this is a T, so it can't be a Z. Is there a Z over here? Okay. Now they want to know if it's one-sided or two-sided. So they want to hear. They said determine if in fact if brand A batteries last longer. So that would be a greater than sign. So that would be a one-sided. So the answer is B. Now it would be a two-sided if they said not equal to.